Okay, so let me share my screen. Okay, so I hope my screen is visible, right? So let me go to one by one project that we are going to do. Okay, so this is going to be our first project with the Docker actually. So where different concepts of the Docker got involved. Okay, so we have involved the Docker file, Docker volumes, Docker compose, Docker networking, container communication. Okay, we are going to deploy our two different applications, that is student store application and MongoDB application, into a custom network. Okay, if you are confusing, if you think that I am speaking a little bit technical, please bear with me. You will be able to get all these concepts very clearly in our sessions. Actually, do not worry as of now. Okay, just I am my duty is to explain you what we are going to do in our project in our projects actually. So you need to get that. Okay. So now what we are going to do is we are going to deploy two different applications, that is Student Store and MongoDB, and we are going to establish a communication between two different applications as a Docker containers. We are going to deploy them as a Docker containers, and we are going to do some port forwarding to our local machine, and we are going to access that application. Okay, so from our Postman as well as a Mongo Compass in order to view the data, and Postman in order to send the HTTP request from our to our Student Store application, right? So you can see that all these things, whatever you are seeing as part of this project number one, everything will be automated using Docker Compose. Docker Compose is a manifest file with which you can perform the automation. All the things we will be automating using the Docker Compose. This is the project number one that we are going to do actually. Okay, automation of two-tier application deployment with the Docker Compose and with the Docker files. All these concepts of Docker which we are going to discuss will be included as part of this project number one. Okay, so the project number two is with the Kubernetes. Okay, so this is the project number two. I have explained the project number two today to our morning 8 a.m. batch. Let me show you the architecture. This is how it is looks like actually when we draw manually. See, before explaining any project, I will be drawing the diagram again in the classes, something like this, so that it will be very clear for you, something like this. Okay, so let me go here to this place to our preview. Okay, you can see that here what we are going to do, we are going to deploy our two-tier application by involving the Kubernetes components. Okay, so like dynamic volume provisioning, persistent volumes, persistent volume claims, pods, deployment, namespaces, okay, replica sets, cron job, okay, ECR. Okay, we are going to use the AWS service called ECR. Before, if you are using AWS services anywhere, anytime, if we use the AWS services in the course, first we will be exploring the service. Okay, what is AWS ECR? What is it used for? And then I'll be using that ECR. Without exploring, I won't directly inject into our project actually. Okay, so we will be using services. We will be using liveness probe, readiness probe, startup probes, horizontal probe, autoscaler. Okay, secret, config map, limits, resource requests and limits, namespaces, resource quota, jobs, cron jobs, all these things we are going to use as part of this project number two actually. Okay, so we are going to deploy it's all our real-time projects. Okay, how the real-time, how the one microservice is going to communicate with the other microservice, we are going to see actually in as part of the Kubernetes, and we are going to access this application from our Postman, which is deployed to the Kubernetes cluster. Okay, so we are going to perform the HTTP GET request and POST request, something like this. Okay, so if I am speaking anything technical, again I am saying, do not worry as of now. It will be very clear for you as part of the course explanations. Okay, this is project number two. Okay, the project number three we are going to discuss is this one. The difference between the project number two and the project number three is the networking as well as the security. Here we are going to use the domain. We are going to purchase a domain. I have already purchased for you. Okay, we are going to purchase a domain from the GoDaddy, and we are going to integrate the domain. What is the domain? Okay, domain is something like a website name, youtube.com, that's a domain, right? So something like that. For our own application, we are going to purchase a domain. Okay. So we are going to integrate our application with that domain. Okay. So then after integrating, what you will do, you will just type www.xyz.com. Then your application is going to open automatically. So in that manner, we are going to use the Nginx ingress controller and the Kong ingress controller as part of this networking project, along with the role binding, cluster role binding. Okay, this comes under RBAC of our Kubernetes actually. So all these things we are going to do as part of the project number 3. The difference between the project number 2 and the project number 3 is the networking as well as the security which are involved in the project number 3 but not in the project number 2 actually. Okay, so that's what you need to remember. Now that is going to be our project number 3. Okay, do not worry, we are going to see very clearly. Okay, so here, this is the project number 3. The project number 4, we are going to have all these components deployed like this one. This is going to be our Kubernetes cluster. We are going to Helmify our all the Kubernetes manifests using Helm charts. And whenever there is any change that is happening in the GitHub repository, automatically a Argo CD is a tool which is performing a GitOps way of deployment to our Kubernetes cluster, which we are going to integrate our Argo CD with the GitHub as well as our Kubernetes. Whenever there is a change in the GitHub repository, automatically Argo CD will deploy the change to the Kubernetes cluster without we manually interacting with the Kubernetes cluster. And we are going to manually, okay, we are going to visualize the Kubernetes cluster using the Kubernetes dashboard application as well as K9s is the application. It's a client-side tool with which we can use, with which we can visualize our Kubernetes cluster. Actually, you can see that here. This is going to be our K9s tool. We are going to do this project number 4. Actually, it's the project number 4. Okay, the project number 5, which we are going to do is this one, EFK stack log collection. Okay, you might have deployed your application to the Kubernetes cluster, but how to collect the logs from the Kubernetes cluster? What is the architecture? Okay, so how to collect the logs? All these things we are going to see as part of the project as part of this project. Actually, there is going to be a fluent bit deployed as a daemon set. What is a daemon set on all the things we are going to be see actually into the Kubernetes cluster, and this pod is going to fetch the logs from the Kubernetes cluster application deployed into the Kubernetes cluster, and the logs will be sent to Elasticsearch. Elasticsearch is a place where we are going to store our logs, and from the Elasticsearch, our Kibana is going to request the logs, and we can view the logs as part of the Kibana dashboard. Okay, so this is how the logging is going to work in Kubernetes. This is also we are going to see as part of the Kubernetes logging framework. Okay, EFK stack. It is very important. Okay, the project number 6 is this one. To look simple, actually, I have put something like this, but yeah, actual architecture diagram will be this one actually. Okay, our actual architecture diagram will be this one. Okay, what will happen here? Our Prometheus server will be there, which will be continuously fetching the metrics from our Kubernetes cluster. And what are the metrics? Like metrics means CPU, memory consumption, CPU consumption, CPU utilization. Okay, so how many number of HTTP requests are coming to our application? Okay, how many people are requesting to your application? Out of those requests, out of those people, how many people got errors? When your application is when they are accessing your application, all such metrics will be pulled by this Prometheus server. Okay, and from this Prometheus server, Grafana is going to fetch the metric that is being pulled by Prometheus, and you can visualize. We can create a visual dashboards, something like this using the Grafana. You can see that this is a visualization tool we are going to see as part of the Grafana. Actually, you can see that here Grafana. Actually, the architecture diagram is this one. Okay, but to make it simple for you, I have put this one. You can see that here, this is going to be our Prometheus server. Okay, this Prometheus server will be uh, getting the getting the okay getting the metrics from the Kubernetes cluster, and the Grafana is going to pull the metrics from the Prometheus server, and we can view our metrics related information as part of the graphs or nice dashboards as part of the Grafana. Okay. Now here we are also integrate. We are also going to integrate our Prometheus server with the alert manager. And alert manager is a component of is one of the component where we will be able to get the alerts actually. Suppose in the Kubernetes cluster, any application is down. Okay, suppose I have deployed an application, Nginx application, and the Nginx application seems to be down. Okay, so whenever the application is down in the Kubernetes cluster, you are going to get the alert to your whatever the configured channel, whether it is pager duty, whether it is email, whether it is Teams, whether it is Slack, okay, whatever channel you have configured as part of the alert manager, you will be getting the alarm as part of uh, the Slack channel. Let me show you how you are going to get the alarm actually. You can see that you are going to get the alert that is being fired, something like this. Okay. So once the alert is resolved, okay, once the application is up again, you will also get something called resolved. Okay, something like this. Okay. So like that, we will also do the alerting. Okay, whenever the application goes down, the alerts you will be getting as part of your Slack channel or whatever you configure actually. Okay. So this is going to be our project number uh, what project number 6. Okay, now the next is the optional project where it includes the STO service mesh as well as the Kiali for the traffic management. But this is I'm placing as an optional project because it's a very advanced project. If you understand all these things only, then this will be clear for you. Okay, so yeah, I am keeping as optional because uh, based on your understanding, I'll be explaining this project. That's why I'm mentioning as option. Okay, this is a project number 7, and the project number 8 is going to be this one. Okay, that is entire Jenkins pipeline we are going to deploy as part of that. We are going to have as part of the Jenkins console. Okay, what we are going to have is we will be pushing as a developer. We will be like we just think we are a developers. Okay, we will be pushing our code to this GitHub repository. Whenever we push the code to the GitHub repository, our Jenkins will be triggered automatically. Suppose this code is Spring Boot application in the code which is there as part of the GitHub repository is the Spring Boot application. Just think like that. Okay, whenever we push our code to this GitHub repository, our Jenkins pipeline is going to be triggered, and our Maven build will be taking place, and this Jenkins pipeline is going to execute the test cases. After executing the test cases, our Jenkins pipeline is going to integrate with the SonarQube. That means our project is going to integrate it with the SonarQube. It will show you the any duplicate code or any vulnerabilities as for the SonarQube console, and it will also have something called quality gates. All these things can be done by the SonarQube. Okay, we are going to integrate with the SonarQube. And after the SonarQube integration, okay, so next step is storing the artifacts. Here we are going to store the artifacts as part of the AWS S3. Okay, here I have used JFrog, but here you can also store the artifacts as part of the AWS S3. And once the storage of artifacts has been completed from our application, okay, what's an artifact? All these things I'm going to discuss, but yeah, do not worry as of now. Okay, just listen. If I'm speaking technical, so do not worry. It will be very clear for you as part of the course. Okay, when we are discussing about the course. Once the artifacts has been pushed to the S3 bucket, our Docker image is going to build actually. Okay, this our Docker image is going to build. Once the Docker image is being built, and the scanning of the Docker image is going to be done by this Trivy tool. Once the scanning is completed, our the Docker image is going to be pushed to the hub.docker.com, that is Docker Hub. And once the Docker image is pushed, we are going to perform the cleanup activities to make our Jenkins available with the space actually. Okay. So we are going to perform the cleanup activities like removing the Docker image, removing the unwanted things from the Jenkins machine, all those things we are going to do. Okay, once the cleanup activities got completed, uh, okay, once the cleanup activities got completed, a downstream project is going to be triggered as part of this Jenkins. Actually, what that downstream project does, whatever the new code will be there, a new version of the Docker image got created, right? So that version will be updated as part of the GitHub repository, and this updated change will be automatically detected by the Argo CD. Argo CD will perform the deployment automatically to the Kubernetes cluster. and we can achieve this. Okay, something like this. Okay, here, project number 8 is entire automation. Project number 8 is entire automation. That means once the developer push his code to his Spring Boot application or the Java application to the GitHub repository, everything from there is automated until the deployment, okay, of that application to the Kubernetes cluster. This is going to be our project number 8 actually. Okay, this is going to be our project number 8. It's entire automation. Okay, we are going to set up this. Okay, we are going to set up this. Okay, so yeah, these are the different projects that we are going to do. Actually, 7 different projects. Okay, this is, as I mentioned, this 7th project is optional project. Okay, as this includes very advanced knowledge in Kubernetes. Okay, so this 8 actually. So along with this, we have 7 different projects as part of this course actually. Okay, so you can go through the course content as part of this DURGASOFT website. In this place. Okay, I've already explained this course content, what we are going to say as part of this sessions. That session is uploaded to the YouTube DurgaSoft channel. Okay, you can also view that session from there. Okay, so all these things what we are going to see as part of this course, I've explained in the last class, that is on Friday. Okay, no, now any questions anyone has? Anyone has any questions, please? Okay, is that projects are interesting? Okay, okay, no problem. Okay, so now how the people deploys their application to our servers? Let's discuss that. Okay, so let me help you with the diagrammatic part. Okay, escape. Let me go to this particular place. Okay, file, new. Okay, so suppose this is B. Okay, this is a developer. He is going to be a developer who develops the application, and we are going to take the example of Spring Boot application. Actually, we are going to take the example of Spring Boot application. He's a developer, something like this. Okay, this developer, what he does, we are going to have our GitHub repository. What is this GitHub repository? GitHub or whatever is Bitbucket or GitLab. Okay, where our code will be stored. Okay, so this is going to be our GitHub repository. This is going to be our GitHub repository. Okay, this is going to be our GitHub repository where our developer push his code to the GitHub. GitHub. Okay, so this code will be cannot be, see whatever the code that the developer has pushed. Suppose let's think this is a code. This code cannot be directly deployed onto the server. Okay, this code cannot be directly deployed onto the server. What you need to do? This code, you need to, as we are discussing about the Docker, you need to convert into an artifact. Artifact like, okay, so it's like a zip file. Okay, it's in Java we call it as a jar file in which our project is going to be present. Okay, so it's a compressed project actually. That is jar file. This is a jar file. Okay, jar file actually. Okay, in which our project is going to be present. Okay, so this is our project, which is developed by the developer, will be pushed to the GitHub repository, and this file will be converted into jar file. Okay, this is how the real-time people follows actually. Okay, okay, from this jar file, we will be having something called Docker file. Okay, we are going to deploy these applications as a Docker using Docker actually. Okay, so this jar file will be included as part of the Docker file. We are going to have something called Docker file. Okay, this jar file is going to be included as part of this Docker file. Docker file. Okay, so this Docker file will be converted into a Docker image. Okay, this Docker file will be converted into a Docker image. Okay, this is going to be our Docker image. Okay, this Docker file is going to be converted into a Docker image. Okay, this Docker image will be pushed to where Docker registry. We will be having something called a place called Docker registry, where all our Docker images are going to be stored. This is going to be our Docker registry. Okay, this is going to be our Docker registry. Docker registry. And from this Docker registry, okay, the image will be Docker image will be stored as part of the Docker registry. We are going to have our server, our Kubernetes cluster. This is going to be our Kubernetes cluster. Okay, so whatever it is, Docker host or whatever it is, server. Okay, this is going to be our multiple servers we have as part of this cluster. Just okay. And the image which is stored as part of this, I have told you, right? Docker image will be stored as part of the Docker registry, right? The image will be pulled from this Docker registry and deployed to this Kubernetes cluster. Okay, so this is how the real-time people follows actually. Kubernetes cluster. This might be uh, this might be old thing for you, some of you people, because you might have following this from many times actually. So this is how our project will be going to be deployed to our Kubernetes cluster or our okay. So developer. Okay, so something like this. Okay, so yeah, anyone have any questions with this process, please?
Inside the Kubernetes cluster, what are those three things that is servers are?
Yeah, this is a combination of servers. Is combined known as cluster. These are three are servers.
Okay, thank you. What is the difference between Docker file and Docker image?
Yeah, from the Docker file only you are going to create a Docker image. Docker file is a set of statements, okay, with which you are going to create a Docker image actually with the help of Docker file. There is a difference. We will be discussing about that.
Okay.
Yeah. Okay. Is that process clear for everyone? Is this process clear?
Yes.
Okay. Okay, this is the same process that is followed in the industry actually. So here I have taken the example of Spring Boot application or the Java application. It is same for all the different applications, whether it is .NET, whether it is Python, whether it is whatever the application it is, whether it is JavaScript or the Flutter or front-end applications, whatever the application is, it is going to be followed who are following the microservices uh, architecture actually. Okay, so now this is going to be the thing. Okay, so now let's move further actually. This is first you need to understand this process. Okay, so what I want to do is let's move with this here actually. So I've already mentioned This course is all about the Jenkins, Docker, and Kubernetes, right? So now, see, tutor introduction I've already mentioned in the last class actually. So whoever knew, I am Shiva. So I have overall 8+ years of experience. I work with multiple technologies actually. Initially, I started my IT career as a developer with Java, Spring Boot developer actually. But gradually, I have shifted my domain from developer to domain, from developer to DevOps, and I hope multiple certifications, AWS Developer Associate, Kubernetes Administrator, and Terraform Associate certifications. Okay, this is my introduction as a tutor introduction, which I've already mentioned. Okay, general introduction, as per the general introduction, which I've mentioned, is the only prerequisite that is required for you is the AWS account. Anyway, laptops will be there with you, or the computers will be there with you, to practice our labs. But the only prerequisites as part of this is the AWS account. That too, how to create an AWS account, I am going to show you very clearly as part of this course. Okay, that is a general introduction I have given. I have also explained the course content and the projects. Today I have explained the project, but yeah, in the previous class also I have explained in the last Friday class, I explain the course content as well as the project. Okay, presentation I have given. Okay, so that's a thing actually, course introduction. So the next thing is going to be, this is our agenda as part of the next part actually of this course. What is DevOps? What is an application? What is SDLC? This might be very basic for most of you, but yeah, as I've already mentioned, this course will be started from very scratch. Okay, okay, so what is a server? What is a physical server? What is Docker and Kubernetes? Where Docker and Kubernetes fits in software release process? All these things we are going to discuss. Okay. So what is DevOps actually? Okay, DevOps is a combination of development as well as operations. What is development? Development in DevOps is not an application development. Okay, development in DevOps is not an application development. Development in DevOps is developing the scripts to automate the tasks actually. Okay, whatever the manual tasks you do regularly, you need to automate the task using the scripts. Whatever the scripts it might be the shell script, it might be the Python script, it might be the Groovy script. Okay, whatever the scripts it might be, you need to write a scripts in order to perform automation. Okay, that's the development in DevOps actually. And you also need to know the application functionality. You no need of writing the code for the application, but yeah, what you need to know as per the application. Okay, so uh, you need to know functionality of the application. Okay, what does what? Okay, what component does what with this application? Something like that. Okay, that comes under development. And operations. What is operations in DevOps? Operations means maintenance. Maintenance. What is maintenance? Okay. So whenever a new version of the application is being created by the developer, you need to deploy. Okay, you need to perform operation. You need to deploy that to the whatever it is, production or the development environment, whatever it is. Okay, maintaining the servers. Okay, you need to regularly updating the servers with security patches. Okay, upgradation of operating systems on the servers. So all these things comes under operations when we come into DevOps actually. DevOps contains two fields, dev, ops. Dev means development, ops means operations. Development and operations is combined known as DevOps actually. At each and every stage of DevOps, we have many tools involved which we need to use actually. Suppose if we talk about CI/CD, we need to use Jenkins. Okay, not it's just an option. We have much more tools actually, but yeah, Jenkins is a popular one out of those. If we talk about configuration management, we need to use Ansible or Puppet. Okay. If we talk about deployment, okay, or orchestration, you need to use Kubernetes. If we talk about monitoring, you need to use Prometheus and Grafana. So each and every stage in DevOps involves set of tools actually. Okay. So you need to use those tools in order to achieve the DevOps principles. Okay. So So out of those tools, our main concentration will be on three tools: Jenkins, Docker, and Kubernetes. Okay, so that's what the thing is. Okay, what is DevOps? That's the thing. What is an application? Application is simply nothing but a website. Okay, right? So if you might have entered into different applications in your real time, in your regular life, right? So you might be went into Redbus, right? You might be went into the Amazon.in. Okay, you might be going to the Book My Show. Okay, all these are applications that is deployed somewhere. Okay, deployed on the servers, so that only you are able to access from your laptops, right? So using the internet. Okay, so that's an application. Application is nothing but it's which satisfy our functionality, whatever our needs actually. So that's an application. You already know what is an application, right? So what is SDLC? Okay, SDLC is a software development lifecycle. So it might be known to all of you, but yeah, I need to explain this. Okay, as part of the SDLC, there will be a six different phases. Okay, analysis phase. Okay, or the requirement phase where the people will be collecting the requirements. Okay, so requirements means how many people are needed in order to do this project. Okay, what are the different things are needed. Okay, something like that. Requirements will be collected in the analysis or the requirements phase. The next phase is going to be the design phase, where the design of our application will be there. Okay, the UI UX designers will be there, or the system design will be happened as part of the design phase. There will be a design patterns will be there actually, so with which the applications will be designed, right? So what is design actually? Suppose you have a login screen. Okay, so where you need to enter the username password, where that username password field should be displayed on this page to enter by the user actually. So whether it should be the top, right, bottom, or the left. Okay, so that kind of design will be happening, or the system design will be happening in the design phase actually. Okay, the next phase, once the design phase got completed, this design app that is the designs will be given to the development people actually. Okay, in the development phase, the developers will be developing the application. Okay, there are two types of developers here: the front end developer and the back end developer. Back end developer will be developing the back end applications, and the front end developer will be developing the front end applications. That means UI related things. Okay, so that's a two types of developers. Okay, the development will be there as part of the development phase, and here they will also be writing the unit test cases where unit testing is going to perform. They are going to use some frameworks called JUnit, Mockit, and PowerMock in case of Spring Boot. Okay, so they are going to use those frameworks and they are going to perform the unit testing. The developers itself performs write the unit test cases as part of their application actually. Okay, in the development phase. Once the development phase got completed, the next phase is going to be testing phase where the testers will be there actually. Okay, so and different types of testing will be performed on our application, whether it might be the regression testing or the stress testing or performance testing or whatever the testing that will be performed on our application will be done in this testing phase actually. Okay. So the next phase is the deployment phase. Okay, here is where our Docker and Kubernetes comes into picture. We are going to deploy our applications, okay, using Docker and Kubernetes, which comes under deployment phase actually. Deployment phase actually. Okay, so the maintenance phase, once the deployment phase completed, the maintenance phase is maintaining the applications regularly, releasing the applications, new versions of the applications. Okay, you need to always make sure that the application is up and running always, and the traffic is served by that application, something like that. Okay, all this comes under maintenance phase as part of this SDLC, software development lifecycle process. Right. So these are the six different phases of software development lifecycle, and our Docker and Kubernetes comes under deployment phase in this SDLC process. Right. So the next thing is, what is server? Server is nothing but a, like, see, suppose you have developed an application. You have developed an application. Okay, until and unless you install, you deploy that application somewhere. Okay, you cannot access that application. Suppose someone developed a book measure. How are I able to access that application from my machine? Because that is deployed on a server and that is made available to everyone of us to satisfy our needs actually, right? So the server is a component on which we are going to deploy our applications so that it can be accessible to the people whoever it want actually. Suppose there might be the internal applications with the company also. Okay, so those applications will be only accessible by that company itself. And there might be the public applications like Amazon.in and the Book My Show. So those applications will be accessible to everyone in the world actually. So that's a server on which we place our application, we deploy our application. That's a server. Okay, there are where does Docker and Kubernetes fits in SDLC process? The Docker and Kubernetes fits is the deployment phase in this SDLC process. You already know that previously we were discussing the 6 phases of SDLC, right? So we have different types of servers in this. In this also, there are two types of servers. One is physical server and the virtual server. What is physical server? Physical server is a server with which we can touch and feel actually. Okay, suppose your laptop is a physical server. You can touch your laptop and right, so you can interact with your laptop. This is a physical server in which you can deploy your applications. Okay, you can install the softwares. Okay, that's a physical server. But there are other servers that we have that is called virtual servers actually. That means you cannot touch like your laptop. Okay, that's a virtually available. You can only interact with that virtual servers, but you cannot touch that. Okay, so some of you people might have installed the Oracle VirtualBox in your machine, and that creates multiple servers in your local machine, right? So that those servers which is created by the Oracle VirtualBox are the virtual servers actually. The physical server is your laptop. On top of that, your laptop, you have installed the Oracle VirtualBox. With the help of Oracle VirtualBox, you have created one more server on your laptop that is called virtual server. You cannot touch that server. You can only touch your laptop, but not that server which is created by the Oracle VirtualBox. Actually, that is virtual server. Okay, that is virtual server. Okay, there are two types of servers, that is physical server and virtual server. Initially, people used to deploy their applications on the physical servers. Okay, people used to deploy their applications on the physical server. There are some disadvantages if you deploy your applications on the physical server. Suppose this is going to be our physical server. Okay, suppose Suppose this is going to be our physical server. This physical server is going to have some 10 GB, 10 GB of RAM. Okay, 10 GB of RAM, 10, 10 CPUs, 10 CPU. We have 10 GB of RAM and 10 CPUs as part of this physical server, right? So suppose I have deployed an application to this physical server. Okay, I have deployed an application to this physical server. Okay, which is using this is app one. Okay, I have deployed app one. Okay, suppose this application is only using 1 GB of RAM and one CPU, CPU. Out of this 10 GB of RAM and 10 CPUs that is there as part of this physical server, this application which we deployed on this physical server is only using 1 GB of RAM, one CPU. Now, what about remaining 9 GB of RAM and 9 CPUs? Okay, 9 GB of RAM is left out and 9 CPUs is also there because only 1 GB of RAM, 1 CPU is used by this application. Okay, remaining 9 CPU and 9 GB of RAM is wastage. Okay, so the first disadvantage if you deploy the applications on these physical servers is the resource wastage. Okay, so the resources means CPU and memory. This disadvantages of deploying applications in physical server. Okay, the first disadvantage that we have as part of the deploying application in the physical server is resource wastage. Okay, so that's a resource wastage. Suppose I want to deploy one more application onto this physical server. Okay, I want to deploy one. I have application number two. I deploy that application again. Okay, I want to deploy that application. So in order to deploy one more application, you need to purchase one more physical server in order to deploy that particular application on that physical server actually. So if you deploy if you purchase multiple physical servers, something like this, okay, you need to have a big space. You need to have a big space, okay, in order to install that physical server, in order to maintain that physical servers. You need to have a separate team in order to maintain the physical servers. Okay, you need to have much money in order to purchase that physical server. So the second disadvantage will be the huge cost actually. Okay, huge cost. If you deploy the applications on the physical servers directly, there are multiple disadvantages. We first disadvantage we have seen is resource wastage, and the second disadvantage we have seen is second one is huge cost. Second, the next disadvantage we have already seen is maintenance is more. Okay, because if you have one physical server, you can easily maintain that, but if you have multiple physical servers, you need to maintain different multiple physical server. You need to create one team and you need to assign that to one team actually, maintenance of physical servers. There will be high maintenance actually, high maintenance. Okay, there will be high maintenance. Okay, the fourth disadvantage that we are going to have if you deploy the applications on the physical server is this one. Okay, let me tell you. Okay, suppose this, I have deployed this application on this physical server. Okay, suppose you can see that I have deployed this application on this physical server as part of this diagram. Okay, suppose if this physical server has been crashed by something happened to the physical server and something happened. Okay. So if the physical server is crashed, the applications that are running on that physical server will also be crashed. Right? If the physical server is crashed, the applications which are running on that physical server will also be crashed. Right? So with this one here, there is no high availability. That means even though the physical server is crashed, okay, immediately the application should be redeployed into the new server. Okay, so without we manually interacting with it, actually, that the disadvantage that we have, uh, if you deploy other disadvantage that we have if you deploy the application on the physical server is no high high availability. There is no high availability. These are the like that. If you talk, there are many disadvantages if you have deploy if you deploy your applications on the physical servers directly, something like this. Okay, so because of these disadvantages, we instead of using physical server, people used virtual servers and virtualization to deploy their application to this to deploy their applications. Okay, this is a physical server. Okay, so because of these disadvantages that we have, if you deploy our application on the physical server directly, people will not is not used. They are not using physical servers to deploy their application. Previously, they used to do, but before the virtualization concept is going to appear, previously they used to deploy their applications on the physical servers only. But after the virtualization concept is came into the market, so they all the disadvantages that we have, most of the disadvantages that we have in case of deploying applications to physical servers is been removed in case of virtualization in the virtual servers actually. Okay, so yeah, anyone have any questions with this process? Anyone have any questions? Is that clear? Okay. Okay, anyone have any questions today actually? Okay, if no questions, what we are going to see tomorrow is how these disadvantages are removed as part of the virtualization. What is virtualization? What are virtual servers? And what are the different types of virtualization softwares are available? What is the advantage that virtualization software will be giving us? Okay, and how these disadvantages that we have with the physical server are removed as part of the virtualization. All these things we are going to discuss in tomorrow's class actually. If you have any questions, you can ask. Any questions, please?
Yes, sure. Srinivasan here. So
Yeah.
not part of this one, but Kubernetes side. So you are
Mhm.
going to cover the Kubernetes. Is it on the cloud environments like EKS or GKS kind of thing, or you will be covering the Kubernetes which we are installing on the particular VM and like?
We will be seeing as per the cloud EKS.
Okay.
Yeah.
So okay. So we are not going to install the Kubernetes on the VM and make it as a Kubernetes cluster on a particular VM, or because
We will also we will also be doing that using KubeADM way. Okay, but
Mhm.
nowadays people are not using that particular way of using Kubernetes actually. Okay, because those will be having high maintenance for the people who are maintaining the Kubernetes cluster. Whoever using previously also migrating towards the cloud provider Kubernetes cluster actually, whether it is AKS or whether it is GKE or whether it is EKS. Okay, so we will be installing the Kubernetes. That's fine actually, KubeADM way. Okay, but not we are not only entirely working on that. We might be using different types of Kubernetes cluster. Sometimes we might be using KubeADM. Sometimes we will be using EKS. Sometimes we will be using online Kubernetes cluster. Sometimes we'll be using Minikube also. So we will be combinedly using all those things actually. We will not specially stick towards one Kubernetes cluster because you need to get the experience of different Kubernetes clusters.
okay,
Yeah.
because I just gone through some of the default tutorial videos in Kubernetes. I tried to play around of it, but since I could not able to gather more information on that, I thought to take on this course. I was more eager, like I tried to install the Kubernetes on the ECS instance, and I could not able to establish with Ingress. I mean, the load balancer services and all, it is working only on. I heard it will work only on the cloud
Yes,
Kubernetes services. But
yes, because the load balancers will be provisioned there only, right? You cannot provision the cloud load balancers as part of the bare metal EKS, sorry, bare metal clusters, right? So
okay.
yeah,
Yeah, fine. Anyhow, we so more course will mostly cover on the cloud Kubernetes, and the project all whatever you explained will be covered inside the cloud Kubernetes services, right? Using the cloud Kubernetes.
yes, yes. Because that's where the real time comes into picture, right? So, no, sorry.
Okay.
Yeah. Okay. So go ahead and if you someone put something in chat. Yeah, it also works in physical also. Uh, not only in the cloud, it also works in physical as well. Okay. So yeah, that's fine. But no one use physical actually. Okay. So whom should I connect to get old recordings? Which recordings you want? What is his name? Girkar? Ame Girkar? Okay, let me try to see. Tom one hi Shiva, I have been keyboard dispatch. Okay. Got it. Just contact DurgaSoft. Just contact DurgaSoft people. They might be helping you in getting the old recordings. Okay. I'm not. I will not be giving any access because I don't have any access permissions to give to you people. All the non-technical things will be taken care by DurgaSoft only. I have already given you the mobile number and in the last class the email ID, and you can contact that numbers and then you can ask them to get the old recordings, okay? So that they will be helping you, okay? Yeah. Thank you. Thanks for joining. I'll meet you in the next class with other concepts, with the continuation of this concept only. Okay. Thank you. Thank you. Bye.